Welcome to this video in which I want to present Terme-à-LLOD, an approach for simplifying the conversion and hosting of terminological resources as linked data. Terme-à-LLOD was developed as part of the Terme-à-LLOD project that is funded by the European Commission. The project has been developed by Maria Pia Di Buono, Mohamed Fazle Elahi, Frank Grimm, and myself, Philip Simiano. The motivation for developing Terme-à-LLOD is the high effort and skills needed to transform language resources into linked data. And this holds in particular for terminological resources or term bases. The skills that are needed to do this transformation into linked data are various. On the one hand, people need to know about the RDF data model. They need to understand the relevant vocabularies that are needed to perform the conversion into RDF. They need to understand the way how to use these vocabularies or the modeling patterns. They need practical skills for data transformation, for example, XSLT in the case of XML-based resources. They need to be able to set up a web server to host an RDF database, to host also a Sparkle endpoint. They need to understand how to implement content negotiation so that content can be served both to humans and machines. And finally, they need to understand how to represent and generate links to other resources. So this is quite a lot of knowledge and skills involved. And we want to provide an approach that allows to transform resources into linked data without all this knowledge listed here. So basically the goal is to empower users to transform terminological resources to linked data in a few hours rather than weeks or months. And the only assumption is that the resource is available in TBX format. So we follow a virtualization approach. We built on a number of previous building blocks. So on the one hand, we built on a converter that has been developed in an earlier project that automatically converts the terminology in TBX format into RDF. Second, we built on Virtuoso server, basically to host the RDF output and also to expose a Sparkle endpoint so that the data can be queried. And finally, we bundle all these components into a pre-configured Docker container that can be run on different computing environments. So the architecture looks as follows. As input to the Terme-à-LLOD container, we need to provide a terminology in TBX format and optionally a mapping file that specifies how to map proprietary data elements of the terminology into RDF. But this is really optional and can be just used without a mapping file using a standard configuration. Then the TBX to RDF service is involved that transforms the data into RDF. Then we import the RDF data into a Virtuoso database. And finally, a web application is deployed that allows to browse and query the data. And we can also download the RDF at the end or also query the data via a Sparkle endpoint. So let's look at how this would look in practice. So this is very simple to publish and link a terminology, and you can do this in a number of steps. So 5 steps, where the 6th just consists in going to the web application. So the first step consists in installing Docker. In our case, Docker is already installed. So I will walk you through the different steps here. Okay, so first we need to download the actual image of the Docker container. So this is done by this command, docker pull, and then the latest version of the container. So in this case, I see that I'm already up to date, so I have the latest version downloaded already. So the next thing is to run the image as a Docker container. Okay, so we see now that the instance is listening on port 8080. So I could already go to the web application here, and I see basically it is running and all the different components here are deployed. Okay, so what I need to do next is to upload my terminology into the server. So in this case, this is a curl command. I'm going to start a new window here. So here I'm using a curl command to perform a post request and basically send the file solar.tbx containing our terminology to be transformed to the actual server. Okay, so I do this, and then if I go back to the application, I will see that the terminology is there. I can basically inspect the RDF file. I can also, in principle, query the data, so I can post a query here and see all the terms that are there with their corresponding type and the written form. So let's go to the next step now. Assume I want to link my terminology with another terminology, for example, with the intaglio terminology that is hosted here at this endpoint, that also provides a Sparkle interface that allows the data basically to be queried. So with this comment here, I can basically send a request to the server to link the terminology that I've just uploaded to another terminology that is published as linked data on the web. So here I get the message that the linking is successful and complete. So let's go to our web application and go to the browser. So here I can browse my terminology. I can basically look at the terms that exist there. I can also do a search. So for example, let's look for a term like whole. I get also auto-completion functionality. And I can see here basically the information that is provided for the term. And I see here also that it has been linked basically to another term, whole, in the intaglio terminology. So here I see the result of linking. I can see this also here in this other view. So if I go here, I'll see some basic information about the term, plus the terms that this term from other terminologies that this term has been linked to. And I see here that this was linked due to an exact match. Okay, so that concludes the presentation. I think it's clear now that it's very simple to host terminologies as linked data following this virtualization approach. If you want to read more details, here I list the publication that goes into more details, and please feel free to contact us at this email address here if you have any questions or need any help in running the approach. Thanks for your attention, and we hope you enjoy our work.